So let's go ahead and put this over here, and we'll look at, actually I think I like it the other way. So yeah, this is homework 1. So the chain rule problems go all the way to number 10, and then the last 5 are implicit differentiation problems, which we'll look at next time. So let's just go ahead and go through about half of these. So let's look at number 1. Number 1 looks more difficult than number 2 to me. So we've got y equals the square root of x to the 8th plus 7. So they want to basically write in the form g of x, which for us, which we normally write is the inside, and then f of u, which I'm generally calling the outside. So let me just write it using that notation. I don't want to confuse you. I'll just show you how it works. So instead of using t as the placeholder variable, they're using u, which is fine. So our inside here we can clearly see is x to the 8th plus 7. And then the outside function would be the square root of u, or u to the 1/2 power. So that's what they want here. They want us to just type in x to the 8th plus 7, comma, u to the 1/2 power. I'm going to make sure it takes that real quick. Well, let's do the derivative and see what happens. Okay, so for using the chain rule to do the derivative, remember we do inside prime, which would be 8x to the 7th, just using the power rule. And then the outside prime would be 1/2 u to the minus 1/2. So to get the derivative, we just multiply them. So y prime would be 8x to the 7th times 1/2. And then we change u back into the original inside function that it was a placeholder variable for, 8x to the 7th to the minus 1/2. So 8 times 1/2 is just going to leave you with 4x to the 7th. And then you could say, okay, this is times x to the 8th plus 7 to the minus 1/2. Or if you want to switch that back to radical notation, we could say this is 4x to the 7th divided by the square root of x to the 8th plus 7. So I'm just going to write it using the previous line, and we'll see if it accepts that. I'm always curious how much simplification they require. X to the 8th. Because I know a lot of people probably wouldn't do the extra simplification step, so I just want to make sure that it takes that. Okay, so let's go ahead and check that. Okay, so got everything right, so no problem there. Number 2 here, this is an easier problem, same as number 1, so we're going to skip over that. Let's go ahead and look at number 3. So number 3, we have y equals e times 5 square root of x. So our inside function here is just the exponent, 5 square root x, or 5 times x to the 1/2, however you would typically write it. And our outside function would just be e to the u, which makes the derivative of the outside really easy. The derivative of e to the u would just be e to the u. The derivative of the inside would be 1/2 times 5, which is 5 over 2, x to the minus 1. Why did I write? Oh, no, this is right. 5 over 2x to the negative 1/2. So our y prime here would be 5 over 2 square root x times e to the original inside, which was 5 square root x. Right. So our original inside function was 5 square root x, and our outside was e to the u. Our derivative was 5 over 2 square root x times e to the 5 square root x. Should be it. So yeah, all set for number 3. Okay, let's go ahead and do 5. We already did a couple of square root ones, so let's do a polynomial one, even though I think it's probably easier. So this one, you don't have to list the inside and outside, although I'm still going to set it up that way. So we have capital F of x here is x squared minus x plus 4 to the third. So I would say my inside function is x squared minus x plus 4. And my outside function, I'm just going to keep using u since that's what they've been using, is going to be u to the third. So the derivative of my inside function is going to be 2x minus 1. And the derivative of the outside function is just going to be 3u squared. So then f prime of x is 2x minus 1 times 3, and then change u back into x squared minus x plus 4 squared. Typically, I would write the 3 in front, so I would write it in this order, although they're both exactly the same. I just kind of like to write the simplest thing in front. So here we would have 3 times 2x minus 1. Again, it should take all versions of this answer. Times x squared minus x plus 4. Quantity squared. And yeah, so we get the correct answer there. Let's go ahead and do both 6 and 7. These are actually just reviewing the exponential rules, which we've known for a while. I introduced them to everyone early, but let's recall the derivative of e to any power times x. That's just ke to the kx. So for 6 here, if you have a of x equals 5.9 times e to the 0.1x, your a prime of x is just 5.9 times, oh, what am I doing? We're doing antiderivatives. Sorry. No, this is Calc 1. Sorry, I teach Calc 2 right before this. And so yeah, we're using the derivative formula. Bring the k down, which is 0.1 here. So 5 times 0.1, and then times e to the 0.1x. And then, okay, I'll multiply 5 times 0.9. That's just going to be 0.59. Just makes the decimal one smaller. So, and then, oh, so there was, yeah, that's it. So we have 0.59 times e to the 0.1x. And that's it. Again, 7, just for recollection purposes, we'll run through really quick, but it's really easy. Remember, if you ever have the derivative of something like a to the x, the derivative is just the natural log of a times a to the x. So if we have p of t is 4 to the t plus 4. Well, when you take the derivative, the plus 4 part's going to go away. So really, we're just taking the derivative of 4 to the t, which is the natural log of 4, that base, times 4 to the t. So that's just like the old shortcut rule that we learned a bit early. It's common enough that, you're not, in my eyes, you're not really even doing a chain rule with that. It's just worth memorizing. Okay, so that's it for 7. 8 is easy enough. That's a polynomial raised to something. Let's look at 9, and then 10 is very easy. We're just using that rule we did for number 6. So number 6 is just like number 10. Nothing too tricky there. So let's just go ahead and do number 9, and that is probably going to be enough to get you through the first 10 questions on the homework. And again, if you have any other questions, I can always answer those on a case-by-case basis. But I think this should be plenty to get you through. So g of t here is 1 over t to the 7th plus 1 to the 6th. And you might say, oh, well, I can do a quotient rule here. Well, you're still going to have a chain rule on the bottom when you do the quotient rule. But if you're clever, you can get away with making it much easier. If we write this as t to the 7th plus 1 to the negative 6th, then we don't have to do a quotient rule at all. We can get away with just doing the chain rule. So our inside function would be t to the 7th plus 1, and our outside function would be u to the minus 6th. Notice if you plug that inside back in for u, you get exactly this clever form of the outside that we used. So then we can just go ahead and do the chain rule. So the derivative of the inside is 7t to the 6th, and the derivative of the outside is minus 6 u to the minus 7th. So now the work is basically done. G prime of t will be 7t to the 6th times the negative 6, and then u we want to replace by that t to the 7th plus 1 to the minus 7. So 7 times negative 6, that's going to leave us with minus 42 t to the 6th times t to the 7th plus 1 to the minus 7th. Or you can write it as minus 42 t to the 6th divided by t to the 7th plus 1 to the 7th. Up to you. But remember, when you take the derivative of a negative, you still need to subtract 1. That's why I see a lot of students, if they would take the derivative of the outside, they might say minus 6u to the minus 5. Well, that would be the case if you had 6. It would be 6u to the 5th. But with negative 6 minus 1 becomes negative 7. So you have to be a bit careful there. So let's go ahead and type this in. So minus 42. Well, I think I got to start with this. Minus 42 t to the 6th. And on bottom, we have t to the 7th plus 1, again, raised to the 7th. Let's go ahead and make sure that checks out. So number 9, did we get it? Yeah, we sure did. So are there any questions for me on any of these problems? Would you like to see anything in more detail? Anyone have any questions? Okay, well, it's a short meeting today. I think that's about it. I would just go ahead and use the extra time to practice those questions today.